we are going to learn about triangles. Closed figure having 3 sides and 3 angles is called triangle. Let us study about types of triangles. Number 1, equilateral triangle. Equi means equal. Equilateral triangle means 3 sides are congruent. That is, in a triangle, if 3 sides of a triangle are congruent, then triangle is called equilateral triangle. Number 1, in equilateral triangle, all sides are congruent, that is equal, and all angles, that is angle A, angle B and angle C are 60 degree. To find the area of this equilateral triangle, one formula is there. Area of equilateral triangle is equal to √3 upon 4 into side square. To find the height of equilateral triangle, height of equilateral triangle is equal to √3 upon 2 into side. To find the perimeter of triangle, perimeter means the sum of all 3 sides of a triangle. That means perimeter of equilateral triangle is equal to 3 into side. Second type of a triangle, isosceles triangle. Now isosceles means in a triangle, if 2 sides of a triangle are congruent, then triangle is called isosceles triangle. In isosceles triangle, number 1, 2 sides are congruent. Number 2, opposite angles of congruent sides are congruent. Take one example. In triangle PQR, side PQ is congruent with side PR. That is, in triangle P2R, 2 sides of a triangle are congruent. According to the theorem, opposite angles of congruent sides are congruent. Therefore, angle R is opposite to side PQ, angle Q is opposite to side PR. That means angle Q is congruent with angle R. That means opposite angles of congruent sides are congruent. Number 3, scalene triangle. In scalene triangle, all 3 sides are not same, that is different. Take one example. In triangle ABC, length of side AB, BC and AC are not same. That is, triangle is called scalene triangle. Number 4, right angle triangle. In a right angle triangle, one angle is 90 degree. In triangle ABC, angle B is equal to 90 degree. Therefore, triangle ABC is called right angle triangle. Suppose in triangle ABC, side AB and side BC are congruent. Then triangle ABC is called isosceles right angle triangle. That means if 2 sides of a triangle are congruent, then triangle is called isosceles right angle triangle. Friends, let us now study more about triangle. Pythagoras theorem. We can apply this theorem in a right angle triangle. What is the theorem? In a right angle triangle, the square of the hypotenuse is equal to the sum of the squares of remaining two sides. Consider one example. In right angle triangle ABC, measure angle ABC is equal to 90 degree. Side which is opposite to 90 degree is called hypotenuse. In triangle ABC, measure angle B is equal to 90 degree. Therefore, side, that is AC, opposite to 90 degree, that is B, is said to be hypotenuse of triangle ABC. That is, AC is the hypotenuse of triangle ABC. According to the theorem, in a right angle triangle, that is in triangle ABC, the square of the hypotenuse, that means square of side AC, hypotenuse square, that is AC square, is equal to the sum of the squares of remaining two sides. Now, AB and BC are remaining two sides. That means AC square is equal to first side square, that is AB square, plus second side square, that is BC square. Therefore, we can say that hypotenuse square is equal to one side square plus second side square. Therefore, according to Pythagoras theorem, we can say that in a right angle triangle, the square of the hypotenuse is equal to the sum of the squares of remaining two sides. Let us now study how to find the areas of triangle. There are two methods to find the area of triangle. Number one, area of triangle is equal to half into height into base. In triangle ABC, side BC is the base of triangle ABC and side AD is the height of triangle ABC. Therefore, area of triangle ABC is equal to half into base into height, that means 1/2 into BC into AD. Second method to find the area of triangle, that is Heron's formula. According to Heron's formula, area of any triangle is equal to, in the square root, s in the bracket s minus a, in the second bracket s minus b, in the third bracket s minus c, where s means semi-perimeter. What is meant by perimeter? Perimeter means sum of all three sides of a triangle, and semi-perimeter means half of perimeter. That means semi-perimeter is equal to a plus b plus c upon 2, where a, b and c are sides of a triangle. Therefore, according to Heron's formula, area of triangle is equal to square root of s in the bracket s minus a, s minus b and s minus c. Friends, we are going to learn very important topic, that is test of congruence of two triangles. The first test, side angle side test, that is SAS test. According to this test, for a given one-to-one correspondence between the vertices of any two triangles, when two sides and the angle included by them of one triangle are respectively congruent to corresponding two sides and the angle included by them of another triangle, then the two triangles are congruent. Take one example. Now, in triangle ABC and triangle PQR, vertex A corresponds to vertex P, vertex B corresponds to vertex Q, vertex C corresponds to vertex R. In these two triangles, side AB corresponds to side PQ, side BC corresponds to side QR, side AB is congruent to side PQ, and angle ABC, that is angle B, is congruent to corresponding angle Q, that is angle PQR. Side BC is congruent to corresponding side QR. That means side, angle and side of one triangle are congruent with corresponding side, angle and side of the another triangle are congruent. That means these two triangles are congruent by side, angle, side test. Now second test, that is angle side angle test. According to this test, for a given one-to-one correspondence between the vertices of any two triangles, when two angles and the included side of a one triangle are respectively congruent to corresponding two angles and the included side of the another triangle, then the two triangles are congruent by angle side angle test. Take one example. In triangle ABC and triangle PQR, angle B, that is angle ABC, is congruent with corresponding angle Q, that is angle PQR. Side BC is congruent to corresponding side QR. Angle C, that is angle ACB, is congruent to corresponding angle PRQ. That means angle, side and angle of one triangle is congruent with corresponding angle, side, angle of another triangle. Therefore, these two triangles are congruent by angle side angle test. That means we can say that triangle ABC is congruent to triangle PQR by ASA test. Third test, that is side test, that means SSS test. According to this test, if for the given correspondence of the vertices of two triangles, three sides of one triangle are congruent with three corresponding sides of the other triangle, then two triangles are congruent. Take one example. In triangle ABC and triangle RST, side AB is congruent with corresponding side RS, side BC is congruent with corresponding side ST, and side AC is congruent with corresponding side RT. That means side of one triangle are congruent with corresponding side of another triangle. That means three sides of one triangle are congruent with corresponding three sides of another triangle. Therefore, we can say that triangle ABC is congruent with triangle RST by side test. Now fourth test, hypotenuse side test. According to this test, if for the given correspondence of the vertices of two right angle triangles, one side and the hypotenuse of one triangle is congruent with corresponding side and the hypotenuse of the other, then two right angle triangles are said to be congruent. Take one example. In triangle LMN and triangle PQR, both triangles are right angle triangle. In these two triangles, angle LMN is 90 degree. In triangle PQR, angle PQR is 90 degree. We know that side opposite to 90 degree is hypotenuse. Therefore, in triangle LMN, side LN is the hypotenuse and side PR is the hypotenuse of triangle PQR. Now observe the figure. Side LM is congruent with side PQ. Hypotenuse LN is congruent with hypotenuse PR. That means in a right angle triangle, one hypotenuse and a side is congruent with corresponding hypotenuse and side of the another triangle. Therefore, we can say that triangle LMN is congruent to triangle PQR by hypotenuse side test. Number 5, side angle test, that is SAA test. According to this test, for a given one-to-one correspondence between the vertices of any two triangles, when a side, an angle adjacent to it and the angle opposite to it of one triangle are respectively congruent to corresponding side and angle adjacent to it and the angle opposite to it of another triangle, then we can say that two triangles are congruent by SAA test. Take one example. Now in triangle ABC and triangle PQR, now here a side means side AB is congruent with corresponding side PQ. An angle adjacent to it, that means angle B is adjacent to side AB. The angle B is congruent with corresponding angle Q. And the angle opposite to it, that means angle C is opposite to side AB. That means angle C is congruent with corresponding angle R. That means side, angle and angle of one triangle are congruent with corresponding side, angle of another triangle. Therefore, these two triangles are congruent. SAA test.
Point, line and plane. In geometry, point, line, plane are three basic concepts which are undefined terms and can have the representation on a paper. First, point, a fine and tiny dot is called point. The point A, B and C are shown in the figure. Second, line. Look at the figure of a line shown alongside. The arrowheads at the ends indicate that a line extends indefinitely on both sides. A line is collection of points. A line is named with the help of any 2 points on the line. We use arrowheads to represent a line as shown in the figure. This is a line AB. Third, plane. First, the surface of a smooth walls, blackboards, top of a table are some example of it. Second, plane extends indefinitely on all sides. Third, a plane is denoted by using the names of 3 non-collinear points on it, such as plane ABC, plane BCD, etc.
Types of quadrilateral. The first type is a parallelogram. Definition: a quadrilateral having both the pairs of opposite sides are parallel to each other is called a parallelogram. Now see the diagram. In quadrilateral ABCD, side opposite to AB is DC, side opposite to side AD is BC. Now AB is parallel to DC and AD is parallel to BC. That means opposite sides are parallel to each other. Therefore, quadrilateral ABCD is called parallelogram. Now, properties of parallelogram. First, opposite sides are congruent. That means side AB is congruent to opposite side DC, side AD is congruent to opposite side BC. Second property, opposite angles are congruent. Now see, angle A is congruent with C. Angle A and C both are opposite angles. Angle B is congruent with angle D. Angle B and angle D both are opposite angles. That means opposite angles are congruent. Third property, diagonals are bisects each other. Now in parallelogram there are two diagonals, diagonal AC and diagonal BD. They are bisect each other at point O. Bisect means dividing each other into same equal part. That is, OA is congruent with OC and OB is congruent with OD. That means diagonals are bisects each other. Now second type of quadrilateral, that is rectangle. Definition: if one angle of a parallelogram is right angle, then it is called rectangle. Take one example. Suppose quadrilateral ABCD is a parallelogram. Take one angle, that is angle A, is equal to 90 degree. Now, if one angle of a parallelogram ABCD is a right angle, then this quadrilateral is rectangle. Properties of rectangle. First property, opposite sides are congruent. That means in rectangle ABCD, side opposite to AB is DC, side opposite to AD is BC. Property is opposite sides are congruent. That means AB is congruent with DC and AD is congruent with BC. That is the first property. Second property of rectangle, all angles are congruent. That means all 90 degree. Now see, in quadrilateral ABCD is a rectangle. Angle A, angle B, angle C and angle D all are 90 degree. That means second property, all angles are congruent. Third property, diagonals are congruent and bisect each other. That means in rectangle ABCD, diagonal AC is congruent with diagonal BD and diagonal AC and diagonal BD bisects each other. Third type, that is rhombus. Definition of rhombus: a parallelogram having adjacent sides are congruent is a rhombus. In quadrilateral ABCD, side AB and BC are adjacent sides. If in a parallelogram ABCD, these adjacent sides are congruent, then quadrilateral is a rhombus. That means a parallelogram having adjacent sides are congruent is a rhombus. Properties of rhombus. Number one, all sides are congruent. That means in rhombus ABCD, side AB, BC, CD and AD, all four sides are congruent. Second property, opposite angles are congruent. Angle A is congruent to angle C, that is angle A and C are opposite angles. Angle B is congruent with angle D, that is angle B and D are opposite angles. Third property, diagonals are perpendicular bisectors of each other. That means diagonal AC and diagonal BD are perpendicular to each other at point O and they are bisects each other. That means third property, diagonals are perpendicular bisectors of each other. Fourth type, square. Definition of a square: a quadrilateral having all sides and all angles are congruent is called square. Take one example. In quadrilateral ABCD, if side AB, BC, CD and AD, all sides are congruent and angle A, B, C and D, all angles are congruent, then this quadrilateral is a square. Now, properties of square. First property, in a square, all sides are congruent. That means side AB, side BC, side CD and side AD, all four sides are congruent. Second property, all angles are congruent in a square. That means angle A, B, C and D, all angles are congruent. Third property, diagonals are congruent and perpendicular bisector of each other. That means diagonal AC and diagonal BD, both diagonals are congruent and they are perpendicular bisectors of each other. Trapezium. A quadrilateral is said to be a trapezium if one and only one pair of opposite sides is parallel. Take one example. In a trapezium ABDC, side AB is parallel to side DC, that is a pair of opposite side, and side AC is not parallel to BD, that is pair of another side. That means a pair of one and only one side is parallel to each other. That is, in a trapezium ABDC, AB is parallel to DC, that is one pair is parallel, and AC is not parallel to BD. This is called trapezium. Now see the properties of trapezium. In a trapezium, line segment joining midpoints of non-parallel sides is parallel to its parallel sides, and number 2, half the sum of the length of its parallel sides. Take one example. Point P is a midpoint of AC, point Q is a midpoint of BD. The line segment, that is line segment PQ, joining the midpoint of two sides, that is side AC and side BD, that is PQ, is parallel to its parallel side, that is PQ is parallel to AB and PQ is parallel to CD. Second property, this segment PQ is half of sum of its parallel side. That means PQ is equal to half into AB plus CD. That is the property of trapezium. Friends, let us now learn about circle. In this figure, point P is the center of circle. Therefore, segment PA and segment PB are called radius of the circle. Segment AB, that is chord of the circle, passing through the center of circle. That means AB is called diameter of the circle. Definition of diameter: a chord which is passing through the center of circle is called diameter of that circle. Here, AB is the diameter of the circle. Diameter is the largest chord of a circle. To find the length of a diameter, one formula is there. Diameter is equal to 2 into R, that is radius of the circle. To find the area of this circle, one formula: area of a circle is equal to pi r square, where r means radius of the circle and value of pi is equal to 22 upon 7 or 3.14. Now circumference of a circle. Now what is meant by circumference? The circular part of the circle is called circumference. To find the length of this circumference, the formula is circumference is equal to 2 pi r, where r means radius of the circle, value of pi is equal to 22 upon 7 or 3.14. Now observe the figure. Arc AXB and arc AYB are called semicircles. The measurement of semicircle AXB and AYB is 180 degree. That means the measurement of whole circle is equal to 180 plus 180, that is 360 degree. In this figure, AB is the chord of a circle. O dash AXB is called sector of a circle. This arc AXB is called minor arc, and remaining part is called major arc. Shaded portion between chord AB and arc AXB, the shaded portion is called minor segment. See some formulae. Number 1, area of a sector is equal to theta upon 360 into pi r square, where theta means angular measurement of an minor arc. Value of pi is equal to 22 upon 7 or 3.14, and where r means radius of the circle. Second formula, area of a sector is equal to r upon 2 into L, where L means length of an arc AXB. Third formula, length of an arc L is equal to theta upon 360 into 2 pi r. That means 2 pi r means circumference of a circle. Now see here, in this formula, theta means angular measurement of an arc, r means radius of a circle. The last formula, area of minor segment is equal to area of sector minus area of triangle. Now observe the figure, area of minor segment, that is the shaded portion, is equal to area of sector, that is O dash AXB, minus area of triangle OAB. That is, area of minor segment is equal to area of sector minus area of triangle. In this topic, we shall study surface area and volume of some solids. In this solid figure, L is the length of an solid, breadth, that is B, and H means height of this cuboid. To find the surface area of this solid, that is cuboid, there are 6 surfaces. Number 1, back side number 2, upper part, that is number 3, lower part number 4, this is number 5, and this is number 6. Now see the formula. Surface area of cuboid is equal to 2 in the bracket L into B plus B into H plus H into L, where L means length of an cuboid, B means breadth, and H means height of the cuboid. To find the volume of this cuboid, see the formula. Volume of cuboid is equal to L into B into H. Now second solid figure, that is cube. Now what is the difference between cuboid and cube? In the cube, length, breadth and height, 3 dimensions are equal. Therefore, to find the surface area of this cube, formula, surface area of cube is equal to 6L square, where L means side of a cube. To find the volume of this cube, volume of cube is equal to L cube, where L means side of a cube. Now see the another solid figure, this is called cylinder. The first part is called circular part, that is circle, the upper part. Second part is lower part, that is another circle. And third part is a curved surface. To find the curved surface area, that is this part of a circle, we know the formula. Curved surface area of cylinder is equal to 2 pi RH, where pi is an irrational number, value of pi is equal to 22 upon 7 or 3.14. R means radius of the upper circle and lower circle. H means the height of the cylinder. That means Curved surface area of cylinder is equal to 2 pi RH. To find the total surface area, formula is total surface area of cylinder is equal to 2 pi r in the bracket r plus h, where r means radius and h means height of the cylinder. To find the volume of cylinder is equal to pi r square h, where r means radius and h means height of the cylinder.
Now, in this cone, r means radius of circle, h means perpendicular height, L means slant height. To find curved surface area, that is, upper part of the cone, formula is curved surface area is equal to pi r L, where pi is an irrational number and value of pi is equal to 22 upon 7 or 3.14. R means radius of the circle and L means slant height. Therefore, curved surface area is equal to pi r L. To find the total surface area, that is upper part and lower part, formula is total surface area is equal to pi r into bracket r plus L, where L means slant height and r means radius of circle. To find volume of cone, that is inside part, volume of cone is equal to 1 upon 3 pi r square h, where h means perpendicular height. Another solid figure, that is sphere. To find the surface area of this figure, that is the sphere, formula is surface area of sphere is equal to 4 pi r square, where pi is an irrational number. Value of pi is 22 upon 7 or 3.14 and r means the radius of sphere. To find volume of sphere, that is inside part, formula is volume of sphere is equal to 4 upon 3 pi r cube. The last solid figure is the hemisphere. If we cut the sphere from the middle, we get hemisphere like this. In this hemisphere, r means radius of the hemisphere. To find the curved surface area of this hemisphere, formula is curved surface area is equal to 2 pi r square, where r means radius of the hemisphere. To find the total surface area of hemisphere, formula is total surface area of hemisphere is equal to 3 pi r square. To find the volume of this hemisphere, volume of hemisphere is equal to 2 upon 3 pi r cube. Observe this figure. There are two lines, line L and line M, and the third line N is a transversal of line L and M. This transversal line N intersects the line L at point A and it intersects line M at point B. These three lines determine 8 angles at points A and B. We will now consider certain pairs of angles. Number 1, corresponding angles. Number 2, alternate angles. And number 3, interior angles. Let us first consider corresponding angles. Now, in corresponding angles, there are 4 pairs of corresponding angles. Number 1, angle A and angle E are corresponding angles. Angle D and angle H are corresponding angles. Similarly, angle B and angle F are corresponding angles, and angle C and angle G are also corresponding angles. That means, in this diagram, there are 4 pairs of corresponding angles. Now, second pair, that is alternate angles. Number 1, observe the diagram. Angle B and angle H are alternate angles. Angle C and angle E are second pair of alternate angles. Now the last pair, that is interior angles. There are 2 pairs of interior angles. Observe the diagram. Angle B and angle E are interior angles. Second pair of interior angles is angle C and angle H. Friends, now let us study very important geometrical topic, that is angle. Look at this figure. Point Y is the common origin of 2 rays, Yx and Yz. The 2 rays Yx and Yz form angle XYZ. The point Y is a vertex of angle XYZ. The ray Yx and ray Yz are sides and arms of the angle XYZ. Angle XYZ is denoted as angle XYZ or angle ZYX. Now, let us study the types of angles. There are 3 types of angles. Number 1, right angle. See the definition of right angle. If the measure of an angle is 90 degrees, then it is called as a right angle. Look at the figure. Angle PQR is 90 degrees. Therefore, angle PQR is called as right angle. Second type, acute angle. See the definition. If the measure of an angle is less than 90 degrees, then it is called an acute angle. In this figure, angle ABC is equal to 30 degrees, which is less than 90 degrees. Therefore, angle ABC is called an acute angle. Third type is obtuse angle. Definition. If the measure of an angle is greater than 90 degrees, then it is called an obtuse angle. Look at the figure. Angle XYZ is equal to 120 degrees. that is more than 90 degrees. Therefore, angle XYZ is an obtuse angle. Congruent angles. If the measure of two angles are equal, then the angles are called congruent angles. Take one example. Look at the figure. Angle ABC and angle PQR both are equal, say 30 degrees. Then we can say that angle ABC is congruent to angle PQR. That means if the measure of two angles are equal, then the angles are called congruent angles. Friends, now let us study pairs of angles. There are 5 pairs of angles. Number 1, adjacent angles. Number 2, linear pair of angles. Number 3, supplementary angles. Number 4, complementary angles. And number 5, vertically opposite angles. First, let us see number 1, adjacent angles. See the definition. Two angles are called adjacent angles if they have a common vertex, a common side, and their interiors are adjacent. Look at this figure. Angle AOB and angle COB are adjacent angles. In these two angles, O is the common vertex, side OB is a common side, and these two interior angles are disjoint. That means different. Therefore, we can say that angle AOB and angle COB are adjacent angles. Second pair, linear pair of angles. Two adjacent angles are said to form a linear pair of angles if their non-common sides form a pair of opposite rays. That means, look at the figure. Angle AOB and angle COB are linear pair of angles. In these two angles, OB is their common side, OA and OC are vertically opposite rays, and they are collinear. Therefore, we can say that angle AOB and angle COB are linear pair of angles. In this diagram, measure angle AOB plus measure angle BOC is equal to 180 degrees. That means the sum of measure of angles in a linear pair is equal to 180 degrees. Third pair of angles, supplementary angles. See the definition. If the sum of the measures of two angles is 180 degrees, then these angles are called supplementary angles. Look at the figure. Measure angle ABC is equal to 120 degrees. Measure angle PQR is equal to 60 degrees. Therefore, the sum of these two angles, 120 degrees plus 60 degrees, is equal to 180 degrees. Therefore, angle ABC and angle PQR are supplementary angles. Fourth type, complementary angles. See the definition. If the sum of the measures of two angles is 90 degrees, then these angles are called complementary angles. Look at the figure. Angle XYZ and angle LMN are complementary angles. Angle XYZ is equal to 60 degrees. Angle LMN is equal to 30 degrees. Therefore, the sum of these two angles is equal to 60 degrees plus 30 degrees, that equals to 90 degrees. Therefore, we can say that angle XYZ and angle LMN are complementary angles. The last pair of angles is vertically opposite angles. Two angles are called vertically opposite angles if their sides form two pairs of opposite rays. Look at the figure. OA and OB are opposite rays. OP and OQ are opposite rays. That means two angles are called vertically opposite angles if their sides form two pairs of opposite rays. Look at the figure. Angle AOP and angle BOQ are opposite angles, and angle AOQ and angle POB are opposite angles.